Hello there. Suppose someone drilled a hole through the Earth and we're falling through it. For simplicity, we're going to assume that the Earth has a uniform mass density. And our Earth has its mass, I'll call it ME, and some radius, I'll call RE. So let's go ahead and track our position y as a function of time, where y is going to be the location above or below the center of the Earth. Now we know that this gravitational force is going to pull us towards the center of the Earth, and supposing that we have a mass of little m, we can go ahead and quickly write out Newton's second law. My double dot is equal to minus Fg. And I always like to emphasize the sign in physics because that can be hard to track sometimes, right? That you can see that we have this positive upwards displacement from the center of the Earth in y, and we have a corresponding negative force. We're getting this opposite relation between our displacement and our force. So I go ahead and introduce that minus sign. And now from here, I just have to worry about the magnitude of Fg. Right, and we can find out what that magnitude is by thinking about Shell Theorem. Let me go ahead and draw out another picture here. And if we're at some location y, we can break down the Earth into two regions. The first region involves shells of Earth around us, which I've labeled in gray, and the second region involves shells of Earth which are below us. So we have Earth around us and we have Earth below us. And so, question 1, what are the shells of Earth around us going to do? The answer is nothing, right? If you're inside a spherically symmetric shell, that's going to provide no gravitational force on you. That's what Shell Theorem says. So all of the Earth around us is going to do nothing. On the other hand, the Earth below us is going to attract us as if all of its mass was concentrated to a single point mass at the center of the Earth. Right, that's the second conclusion of Shell Theorem, that each of these shells of Earth below us act as though they were point masses located at the center of the Earth, and we add those all together and we get just one big point mass. So let's go ahead and call all of the mass of the Earth below us this script m. And again, we still have our mass, little m, so the magnitude of the gravitational force on us is going to be g script m little m over y squared. Alright, and what is script m, right? It's going to be some fraction of the total mass of the Earth. One way we can think about coming up with the mass script m is we say, look, the Earth is going to have some uniform mass density. If I take the total mass of the Earth, me, and I divide by its volume, 4/3 pi re cubed. Then I take that mass density and I multiply it by the volume of all of the Earth below us, which would be 4/3 pi y cubed. Great, so canceling terms and plugging that in, we now know what Fg is. So let's plug that in Newton's second law. After plugging that in, I'm going to go ahead and move our gravitational force term to the other side of the equation, and I'm going to write it out kind of suggestively here. Big G times me over re squared, what is that term? Oh right, that's the gravitational acceleration at the surface of the Earth, right? What we usually just call little g in physics. So now all of a sudden we have this really nice looking differential equation. We have y double dot plus little g over r times y is equal to 0. And as physicists, we look at this differential equation and we go, bam, okay, I know what this differential equation is. This is the equation for a simple harmonic oscillator, right? If we were to go through and solve it, we would get a solution looking like sines and cosines. As a reminder for that general form of a simple harmonic oscillator, I have chi double dot plus omega naught squared chi is equal to 0, where omega naught is the angular frequency of your oscillation. Right? And so pairing this general form of the simple harmonic oscillator with our expression here, we can assign g over re, well that's that omega naught squared term, right? Or in other words, our angular frequency omega naught is going to be square root g over re. And there we go, now we have a very clear understanding of the motion here. We're going to get simple harmonic motion with an angular frequency of root g over re. And that's it, that's the motion we're going to undergo if we're falling through a uniform Earth. If you enjoyed this video, found it helpful, let me know in the comments and consider subscribing to the channel. I love to hear about people getting on board. But other than that, thank you so much for watching.